Greetings all. Today it is a deep dive on right triangle relations. This exercise actually shows multiple relations on the right triangle and shows also triangle similarities. So we are given this triangle. It's a right triangle ABC. And another one, ADC, they want us to find the area of ADC. There are multiple methods we could use. You could even use trigonometry, but we are not there yet. This is the purpose of this one, is just pure geometry. So if we call X the length BD and Y DC, and then we can say that BC is equal to X plus Y. So we are going to use that and start our calculations. There we go. We just said that BD was equal to X and the DC was equal to Y. We are trying to calculate DC and then AD. We will call it H here, and we are going to use that to calculate the area of the triangle. And if we say BC here is X plus Y, then we can start looking at our triangle. And they gave us that AB is equal to 15 and AC is equal to 10. Okay, so let's start. We have to analyze these triangles and see similarities here. So if we take this big triangle, we have a Pythagorean theorem. We have the legs AB and AC, and we have the hypotenuse. You can say that the hypotenuse BC, or X plus Y squared, is equal to 15 squared plus 10 squared here, is equal to 225 plus 100. So BC squared will yield 325. 325 is a factor of 25. It's like 25 times 13. So if you look at 225, you have 45. What I call it, you have maybe 15 25 there. Okay, and the 100, you have 4 of them. I mean 9 25s into 25, and then 4 in 100. So that means 5 square root of 13, 9 plus 4. Okay, so looking at those triangles, we can name BAD1 and CAD number 2. And if we look at these triangles, if we look at ABC and ABD, we can say that in triangle ABD, we can say that angle 1 is a complementary of angle B, correct? In that small triangle ABD. And if we look at triangle, the big one, ABC, we can say that angle C is a complement of angle B, because they sum up to 90 degrees. So, but you have two angles complementary to another angle. That means these two angles are congruent. That means angle 1 is congruent to angle C. So that is a very important relation we have here. And we can prove the same thing with angle number 2. If we take angle number 2 and angle number B, angle B, you can say that they are congruent. You can use the same method here with this big triangle and the small triangle ADC. Okay. So we have that relationship now. We know that angle 2 now is complementary to angle B. So this is very important for what we are trying to prove here. What we are trying to bring home is similarity between these triangles. Okay. So if we look at the triangle ABC, big one, and the triangle ADB, we can find similarities. So if we look at angle B, we can say this, we are allowed to say that angle B is congruent to itself. Okay, so this is reflection, reflective properties. So angle B is congruent to itself, and we said that angle 1 was congruent to angle C, and for the triangle ABC and triangle DCA or DBA, for angle B here, it will be for DBA. Okay. Okay, thank you. So we have these two triangles which are similar, and the same way we can say that triangle ABC is similar to triangle DCA, because okay, still proving that ABC is similar to DBA. Okay, because of the angle properties here. Okay, so we have that, and the same way we can prove that the other colored triangle also in ABC, they are similar. The same way we proved the first one, we can prove the second one also. We can say that angle C is congruent to angle C by reflective property, and then we say that we already found that angle 2 was congruent to angle B. Okay, and once we have that, we can prove that on the first case here, that BD over AB is equal to AB over BC. Correct? If you look, the first one we took the small triangle ABD, and we say BD, that what I call it, leg BD over the hypotenuse AB, and we could say that in the big triangle, it is like saying that AB over the hypotenuse BC. That means that AB squared is equal to BD times BC, and we come to the conclusion of 15 squared is equal to X times BC. Okay, and we found BC already. We found that it was equal to 5 times square root of 13. So that means we can find X here. Okay, so otherwise X is equal to 15 squared over 5 square root of 13. So if we pull out X here, divide both members by 5 square root of 13, we come to that one. And 225 over 5 is 45 actually. So you get 45 over square root of 13 rationalize the denominator here. You make it for 45 square root of 13 over 13. So that is the value of X. Okay. From now on, it's easy because remember we already found X plus Y or BC. BC was equal to 5 square root of 13. So we have two methods here we can use to find the value of Y. Either we just subtract X from BC, or we use the same method we used for X to find Y. So let's take the first method. Then 10 squared is equal to Y times BC. And when you do that, you get your Y, which will be equal to 100 over BC, which is equal to 5 square root of 13. Okay. But 100 over 5 is just 20. So we rationalize the denominator and we get 20 square root of 13 over 13. So we have X and Y. Now we can use the other method just to prove that we are right. We say Y is equal to BC minus X. So it's equal to 5 square root of 13 minus 45 square root of 13 over 13. So if you put the same denominator, we get 65 square root of 13 minus 45 square root of 13. So we get 20 square root of 13 all over 13. So it is the same result. Okay. Now that we have Y, to find that area we need H, the base or the height. Which one? Anyone can be considered the height, but we need the H here. So how to find H? There are multiple ways, but there is one relation we can prove here. If we look at these two small triangles, we know that they are similar. So by the angle property here of similar triangles, and we can say that triangle ABD is congruent, no, is similar, I would say, to CAD. Okay, that means if we take the big leg over the small leg of one of them, we get the same ratio as the other big leg over small leg of the other one, because these are similar triangles. So we would say that BD over H or over AD is equal to AD over DC. That means we have X over H is equal to H over Y. That gives us that H squared is equal to X times Y. This is very important result also. I tried to do all these ways to show these relations. We have seen the two previous one, and this one also is. These are important for the right triangle deep dive. So we can find H now. Actually, say H squared is equal to multiply X and Y. So 2 square root of 13 over 13 times 45 square root of 13 over 13. That means we get 13, 20 times 45 over 13. That makes it 900 over 13. That is H squared. That means H is equal to square root of 900 over 13 is equal to 30. Square root of 13 over 13. Excellent. So we have that now. We have H and we have Y. And all we have to do is to take half of their product to find the area. So the area we are looking for is 1/2 of Y times H is equal to 1/2 of 20 times 30 times square root of 13 squared over 13. So times 13. So one of the 13 will vanish with the square root squared, and we get 1/2 of 20 here is 10. Area is equal to 300 over 13. That makes it roughly 23.08 units squared. So that's what we are looking for. But there is another elegant way to look at this problem. I just used this long method to show you the similarity of triangles. But what we could use is method number 2. So for method number 2, we look at the triangle ABC. So the area of ABC is equal to 1/2 of 10 times 15. Okay, so that makes it just 75. So that is the area of ABC. Now the small triangle, if you look correctly, you can see that if we find the hypotenuse of the big one, we can compare the two hypotenuses and find the ratio, which we found, because BC is equal to 5 square root of 13. BC equal to 5 square root of 13. Okay? So since we found that, we can say the ratio is equal to, if we take 10 over the hypotenuse of the big guy, so that makes 10 over 5 square root of 13 is equal to 2 over square root of 13 yes, we simplify here. 2 over square root of 13. We rationalize. We can call it 2 square root of 13 over 13. Now, since this is a square, like an area, we can say we have to square that ratio. So that means 2 square root of 13 over 13 squared will give us 4 times 13 over times 13. So that makes it 4 over 13. This is the ratio between the two areas. So now all we have to do is to multiply the area of the ABC by that ratio to find the small area. So area of ADC is equal to 75 times 4 over 13 is equal to 300. It's equal to 300 over 13 as we found earlier, which is roughly 23.08 units squared. So this one was like 4 lines only, but the advantage of the other one is to show all the steps how these triangles are related and show the ratios and some important relationships between h, x and y, and also the other sides. I hope that you enjoyed this video, and have a good one. Thank you.